Hello, friends. Welcome to another Tech Talk. Today, we have the opportunity to talk with a person who has a very unique skill set. He's a Quarkus expert and also a Spring expert. So, I'd like to invite you to the stage. Eric, welcome, Eric.
Hey, thanks, Edson. It's good to be here.
Yeah. Yeah, and I can see that, yes, we have this very interesting subject today, Quarkus for Spring developers. And it seems that you wrote something about it, didn't you?
Yeah, I did. I spent pretty much this entire year since January writing this book that we recently published. Taking a look at Quarkus from the kind of looking at it through the lens of a someone who's familiar with Spring and the Spring concepts and conventions and whatnot, and kind of comparing and contrasting with Quarkus.
Cool. Well, we can't wait to hear more about it. So, we'd like to say that today, live from New Hampshire and Cary, North Carolina, welcome to DevNation.
Awesome, thank you. It's great to be here, and I'll apologize up front for my kind of jerry rigged background here. I couldn't figure out how to get a nice virtual background that didn't make me look like I didn't have any ears. So apologies. It is what it is at this point. So people were probably more interested in looking at the big thing on the screen rather than this little box here on the side, right? So, like Edson said, when I first started off, and a little bit about my background, before joining Red Hat, I have a huge amount of experience in Spring. I worked for a lot of financial services companies where that standardized on Spring, and kind of unique for me is I skipped the whole Java EE thing. I went right from thick client desktop using Swing with maybe a little bit of like servlet based backend to Spring, and I skipped Java EE and all that kind of stuff. So for me, when Quarkus first came out, it was like, okay, how do I learn this? And like anything that anybody's familiar with, not just with technology, but when you're starting to learn something new, you're always comparing it or contrasting it with something you're familiar with. Whether it's technology or cooking or whatever it is that you're doing, you're always looking at it through the lens of something you're familiar with. And when I was starting with Quarkus, everything that I learned and everything I did, when I picked up JaxRS and JPA and all that, the micro profile stuff, it was how does that fit into things that I know? How is it better? How does it make my life easier? But at the end of the day, it's how does it compare with things that I know? And so we decided to actually write a book about it because when you start looking at Quarkus, there's tons of guides out there, and the guides are really, really good. But the guides really focus kind of on one thing, like building a RESTful service or using Hibernate or Panache or whatever. And sometimes it's a little bit different than what a Spring developer might be familiar with. So we wanted to kind of level set and take a look at, well, people who are familiar with some of these concepts, the conventions, the auto configuration, all that kind of stuff. How does that work, and what does that look like in Quarkus? And what does Quarkus do similar, and what does Quarkus do different? And so we tried to do it through code examples by looking at, why did we decide to do Quarkus in the first place, right? What was the problem that Quarkus was trying to solve that's out there? We didn't just decide, or not. I keep saying we. I wasn't part of the Quarkus team, but they didn't just decide, hey, we need a new Java framework out there, just because that there's a reason for it. So why? And then once you kind of get some foundation, and for me, I kind of like history a little bit. So some of the historical aspects of what was going on, what were the challenges, and why we needed this kind of thing. So after that, we took a look at how do you get started. I'm familiar, if I'm a Spring developer, I'm familiar with the initializer, I'm familiar with all the starters and whatnot and what they do. What does that look like in Quarkus? How do I actually get started building something? And then from there, we take it into, okay, REST is pretty common out there. There's a lot of RESTful applications. So looking at like Spring MVC, Spring Webflux, and how does that translate into something in Quarkus? And then extending that, we use this kind of the same example that we started building at the beginning, and each chapter kind of adds onto it. And we added persistence. So looking at both, Spring Data JPA, and Quarkus has this thing called Panache that is kind of like an abstract, or not kind of, it is an abstraction on top of JPA, just like Spring Data JPA is. And so you'll find some of the patterns are very, very similar. Excuse me. And then looking at event driven services. So things like in memory data buses or Kafka events, producers, consumers, Knative, how would I deploy my services into something like Knative? And then once you have your application, how do you operate it? What does it look like? What are the tools available? And when you start looking at containers, Kubernetes, deploying and running on the cloud, what are some of the differences or challenges with either one? And we tried to show that through example. And yeah, I have to give some credit as well to Daniel O and Charles Milliard. They helped co-author some of these chapters. So chapter 5, the event-driven chapter, was authored by Daniel O, and chapter 6 by Charles Milliard. They were fantastic to work with and very, very good. And we actually got somebody from Microsoft to write the foreword. So Martin Verberg wrote the foreword. And what was kind of interesting, um, something that he said in the foreword, which kind of struck with me. I'll make this a little bit bigger so folks can see. What he kind of said is, it's kind of that time in your career. If you are a Spring developer, I know for me personally, when Quarkus first came out, it was like, why would I want to do this? I'm familiar, I'm good, I've got my head down, I'm good with what I've got. But it's kind of like, well, there's kind of this new way of doing things, this build time optimization thing. It's kind of one of those points in your career where even if you don't adopt it, you should at least, stick your head up out of the weeds and kind of take a scan about what's going on out there in the industry, and explore something new in depth. And the book, I feel, makes it easy to do that. And, obviously Martin feels the same way. Otherwise he wouldn't have written it. So I don't want to spend a huge amount of time, looking through the book and the chapters and whatnot. I want to dive into some code, but as you can see, it's pretty in depth about some of the concepts and whatnot. And one thing I try to focus on, me personally, I'm a very big fan of test driven development, and so I write tests for pretty much everything. There's folks out there who might say, oh, there's some limit that you can reach where you're putting more effort into writing a test than the benefit you're getting, and I agree with that. But you need to have a good test suite, right? And a lot of the whether you're Spring, Quarkus, whatever, a lot of the things that you find out there in the internet or Stack Overflow or whatever are how do you solve a problem, but then how do I test what I built? And so within each chapter, we'll spend half the chapter talking about how to build something, and then the second half of the chapter is, okay, now that you build that thing, how do you test that thing? So we focus a lot on testing. Let's see here. So all the examples, there's a whole set of example code that's out there. There's a GitHub repo, and I'm gonna drop into my IDE in a second here. But there's a whole GitHub repo. It's organized by chapter. So for example, we're gonna look at some of the persistent stuff today. So the chapter's organized. There's a bunch of different examples, and when I built the examples, I tried to follow a pattern that they're to keep both the Quarkus and the Spring examples as similar as possible. So to keep the code, and that was kind of one of the focuses on this, was to keep the examples as close as possible. Even might be a better way to do something, but from an understanding perspective, I want the examples to be as close an implementation as possible. And throughout chapter 4, that's pretty much the case. But once you start getting into like the event-driven stuff and the cloud stuff, that tends, and I don't know if you can see my hands, but it tends to branch off and diverge quite a bit from an implementation perspective. But at least they all implement the same use case, so that's helpful. So even in the event driven scenario, we implement the exact same use case, but the implementation is quite different, just because the technology is different under the covers. As far as versioning, it was just like writing a book, with technology. The day it's published, it's out of date. So once you print something in these days, so keeping up was tricky. The examples in the book were published, I think, with Quarkus 2.1.4. So it was published at the end of August. I just recently, yesterday, Quarkus 2.3 came out. So all the examples are up to date with the latest versions of everything. And I'm going to keep doing that as long as I don't have to make code changes that would involve, kind of republishing the book kind of thing. But the Spring examples in the book are 2.5.4, I think, and it's been updated, the repo, to 2.5.5. So the repo is current with whatever the latest versions are at this point in time. And I'm also trying to make notes. So in the main README, I kind of mentioned the versions as well. But then, as new things come out that I didn't necessarily implement in the examples because it would have made me change the text. But I did kind of comment on, what might have, as new things have come out, what I might have done differently in the examples. And if we do a new, V2 of the book or a re-release, in a few months, we may incorporate some of the stuff into it. But I didn't want to change the code in the repo, so that I want to keep it so that it matches what's actually in the book, because I think that would be super confusing to folks. All right, do we have any questions, Edson, on the text? Otherwise, I'm going to drop into the IDE. Not yet.
No questions so far, so please go ahead with the code.
All right, so let's see it. So I've got an IDE. I've got my IDE here. I've got the examples repo loaded up. What I'm going to look at today is I'm going to go into chapter 4, and I'm going to look at, one of the more common things is, I need to build a REST layer and I need to talk to a database. It's a pretty common, architecture right now. And just so what I'm going to do is show a Spring Data JPA example alongside what Quarkus calls Panache, which is its abstraction that sits on top of JPA and Hibernate. Under the covers, both use, Hibernate is the most common ORM tool or ORM engine out there in the community. So they both sit on top of Hibernate as the JPA abstraction. And as you'll start to see, and I've got some code, and I'll explain the code in a second, it's pretty similar. So if you're familiar with Spring, picking up Quarkus, or I like to say Quarkus is based on a breadth of standards. So like JAX-RS, JPA, whatnot. There's not a lot of Quarkus to get in your way. Most of the Quarkus stuff happens at build time, is where the Quarkus magic happens. So on the left here, and I'm just going to minimize that part just to give me some more screen real estate. On the left side, I've got the Quarkus, and on the right side, I've got Spring Data JPA. And as you can see, I can make this a little smaller. Most, in any entity class, this is an entity class. All the kind of magic of an entity class is up at the top. I'm not using something like Lombok, that we can have a whole separate conversation about why not. But I'm not using Lombok. So, under the constructors, there's a whole bunch of, boilerplate getters and setters, toString, hash code, equals, all that kind of stuff. So you don't need to see that. But as you can see, and even if I open the imports here, these classes, if you were to do a diff on them, they're exactly the same. There is no difference between these two classes. You could copy paste one to the other and it would just work because they are the same class. Those who are familiar with Spring Data JPA would be familiar with this repository thing. So in Spring, you build a repository extending, there's a whole different flavor of base interfaces that you can extend. I chose, for whatever reason, this one, the JPA repository. There's a CRUD repository. There's a sorting one. There's a bunch of them. And then I added an additional method to it to find something by name, and it returns an optional whether it was found or not. And on the left side, you've got this this Quarkus or Panache class. So the first thing you'll notice is it's a class instead of an interface. So the reason behind that is Spring Data JPA at runtime, when you start up your application, will scan for all of these interfaces and it'll build dynamic proxy implementations for them. So there's a bunch of different ways you can build them. You can build your own classes and wire them together so that Spring Data understands where they are. But at the end of the day, Spring Data is going to build an implementation of the interface and implement all your methods for you, and it does that at runtime. Whereas with Quarkus, kind of one of the main benefits of Quarkus is it optimizes stuff, and I'm just in air quotes here, stuff on the JVM. So part of that is, well, rather than build an interface, I can actually build a class, and I still have this plethora of base implementations that I can pick from. I just picked the basic one that kind of looks similar to JPA repository, but it provides a whole bunch of CRUD based methods for me, like create pretty much all the same stuff you'd find in the Spring version. And again, I implemented the same find by name, but I actually implemented the method. So you notice I'm I'm finding something and I'm querying by name and returning some optional. Spring Data JPA has a way where I can annotate my methods with like @query. I can do named queries, and I can do all the same stuff with Panache, and it looks pretty much exactly the same. My use cases here are pretty simple. And then the only other thing is the annotation. So by default, Quarkus uses CDI as its dependency injection framework. So because I built an interface, I need to tell the dependency injection container that this is a bean that needs to be injectable within the context. But what's kind of interesting with Quarkus is all this bean injection stuff happens at build time, not at runtime. So like and maybe it make more sense if I actually go to where the class is used. So in Spring MVC, you build a controller class, and in Quarkus uses JAX-RS. So you build resource classes, right? It's just a different naming convention. But all this, you see I'm using constructor injection. That should probably be familiar to Spring folks, because I know the Spring team themselves recommends constructor injection over like at auto-wired fields. When I was committing stuff, a few years ago, if a pull request didn't do it that way, if you did the other way, they would actually deny it and you'd have to go fix it. So they certainly prefer constructor injection. There's a whole slew of reasons why. I personally feel it's better anyway than field level injection, which if you want to have me back, we can have that conversation too. But in any case, they're exactly the way the beans are injected is done exactly the same. But back to my previous point about build time versus runtime, in Quarkus, this binding in the bytecode for binding a bean injection point, which is done by type, just like in Spring, is actually done at build time. So the Quarkus build process will generate all the bytecode and kind of pre-warm the just-in-time compiler, so that when the Quarkus application starts, all that binding and injection, there's no proxies or anything. It's just that the real thing is just kind of there. Whereas in Spring, all that stuff is kind of done at runtime. But you can see, if you're not familiar with JAX-RS, it's very, very similar. So you annotate your class with kind of a base path, just kind of like in Spring, you do a request mapping, and then you just implement your method. So in Spring, all the mapping annotations, get mapping and put mapping and post mapping and all that kind of stuff, has all the metadata as part of the annotation. So like the media types and paths and all that stuff. Whereas in JAX-RS, all those, they're all separate annotations. So you've got a get annotation, a produces annotation, a path annotation. And what's kind of interesting, if you notice here, on the Spring side, I've got some validation stuff, which I have over on the Quarkus side as well, from the bean validation spec. And then all the imports are, the typical Spring MVC imports. But on the Quarkus side, there's nothing Quarkus-y. I like to say Quarkus-y here. It's all built on standard. So JAX-RS, I'm using, standard JAX-RS out of the box. Under the covers, though, Quarkus is built on a reactive engine. It uses Netty, which is the same engine that is under Spring Webflux. And in this case, in this example, this is Tomcat behind it. But the fact that Quarkus is reactive doesn't mean you have to build your application reactive. Quarkus will kind of understand what's going on. So in this case, all my method, I'm not doing anything reactive here. I'm not using any reactive types. I'm using, standard JDBC stuff. Quarkus will just kind of figure out that, hey, this method needs to be moved off of the IO thread onto a worker thread. Whereas in the Spring example, everything is done, with the thread per request model. So every request that comes in is on its own thread, so that the developer doesn't really have to worry about that. So other than that, I mean, the implementations, the actual code, like in the methods, is pretty similar. I mean, Spring has this response entity. Quarkus has a response object. If I want to change the status code on the response or anything like that, transactional, doing transactions, it's very similar, except the Spring one uses the Spring annotation for transactional, whereas the Quarkus one uses the JTA transactional annotation. So it's kind of cool if we run this. So in Quarkus, one thing that I can do, I'm going to use Maven here, is I have this thing called Dev Mode. Now, you remember the only thing I didn't show was configuration in Quarkus. I don't think there is any. But when I run the Quarkus application, or I can run it in what's called Dev Mode, Quarkus sees, hey, I have a Postgres driver here, but you didn't configure a data source. So what Quarkus will do is it'll actually bootstrap a Postgres container for me, and it'll bind my application to the container. And you have to forgive my machine. The fans are spinning so fast, I feel like the laptop's going to lift off into outer space. So, yeah, so you can see Docker is, I'm running Docker desktop, but if I was using Podman, it would work just the same. The data source is starting. It's pulling the database. And I actually custom built a database image for this exercise just to kind of pre-populate a schema and preload data into it so that all the examples are based off of the exact same schema. So there's no change in the schema here. And so while that starts up, you see, yep, this thing called dev services started. So it started a database, and now my application is up, and I can start, interacting with it. And if I just do like PIE 8080, come on, there we go. We got some JSON back, right? So that's pretty cool. But what if we kind of start to compare and contrast what's going on? If I go over to the Spring one, so the first thing I need to do is I need to start a database, right? So I need to, where was my database? I need to start my database. I'm going to start the image manually. And while that goes, oops, into the right place. And then I'm going to do, I already built the application. So I'm going to say Java -d spring.data source that URL and JDBC Postgres localhost 5432 fruits and target name of my app here. Sorry. Gotta get the name of my app. Where's my binary? I don't know why my auto completion isn't working. Dash jar. There we go. So my application starting up. Still going. And it's up, right? So now if I go and I do the same thing, and I get it back. But what's kind of cool, if I want to actually look at the process, so I have a little script that will calculate the resident set size. So RSS is the memory footprint of the application, not just the heap size, but all the off heap stuff as well. So if I take a look at that, I could see my application is using 434 megs of RSS space. So now if I kill my application, my database is still up. And if I do this kind of the same thing with the Quarkus one, it's up. And you notice it started in like 4 seconds. What did the Spring one start in? It's going by log 11 seconds. So 11 seconds for Spring, 4 seconds for Quarkus. If I do the same HTTP request, just a funnel request through, and then look at the RSS. That I'm using 184 megs. Same application, same use case, same implementation, and I don't know what the percentages are in my head, but 434 versus 184, and I started up in a third of the amount of time. The other thing, I know we're kind of running out of time here, but I also do, so Quarkus makes it really easy to do this native image stuff. So I could also do, I already built the native image. I'm just going to find the command here. I export the data source, and then I run my native image. I started in, where's my start time? 221 milliseconds. And if I funnel the same request through it, back, and if I do my RSS, 32 meg, 33 megs. same application. So you can kind of see some of the differences here. So I know what do we have? 5 minutes left, Edson? Do we need to pause for questions?
We do have some questions. Actually, people are starting to fire the chat right now. But let's start with the first. So let me get it for you. So I was able to type this one. Like Raja is asking, do you recommend giving up Spring for new products? Probably talking about Quarkus. What do you think?
Yeah, it's an interesting. So it comes back to. I mean, there's a lot of factors that go into it. Obviously, I think Quarkus is a good thing, especially for it's a good thing for Java, and I think VMware and Spring have realized this. I mean, Quarkus wasn't the first to, or about the same time Quarkus came out. That Micronaut was doing something similar with this build time optimization stuff. So I know like at Spring One, they announced that Spring 6, which will be kind of the next kind of major release of Spring, and then Spring Boot 3 will follow that, is targeted for the end of next year. But part of their reasoning is that they want to re-architect and refactor the framework because kind of they see that this kind of build time and ahead of time optimization for Java is a good thing, and that's where industry is going. So I would say, if you're familiar with Spring, as much as I'd love to say, yeah, give it up and don't do it, I don't think that's going to happen. Spring is certainly powerful. I'm still like it. It's a very, not that I don't want to say Quarkus is immature, but Spring is a very mature framework. It's been around for a really long time. But part of, it's kind of a double edged sword. Part of being around for a very long time makes it so that it's going to be really hard for them to re-architect and fit. I mean, if you understand kind of how Spring works under the covers, it's based on a lot of the AOP and dynamic proxying and runtime stuff that when you start looking at this build time, doing stuff at build time kind of goes contrary to that architecture. So, and then having to retrofit that without breaking everything and still supporting everything that's already there is it's going to be tough. I mean, I'm sure they're going to do it and they'll do a good job of it, but um, it's a lot of work. It's going to be a lot of work.
Mm-hmm. Cool. Yeah, now we have a lot of questions just because we started with the first
And
one.
I can go past the half hour if we need to. So
Yeah, cool. Let's try to read the first. And Asif is asking, will you discuss this DB custom image and Quarkus integration? I don't know if I got the question.
yeah, I mean, the custom image I built was just, I took a Postgres, the standard Docker Hub. Yep, sorry. I took
That's why you
the,
know it's live. Yeah.
yeah, now I'm really live when the phone rings, the dog barks or something like that. So the, I lost my translation. Oh, the DB image. So all it was I took the standard Postgres 13 image and I added a init script that creates the schema and then a SQL file that inserts data into it, just to make it easy. Because what I wanted to show and what I didn't show here was, having your application create the database for you when it starts up, populate the schema and whatnot is great for local development. But what it doesn't test is if you're building a JPA entity class and you've got these different annotations, most of the time your app is connecting to a database that already exists. And so how do you test what your application, if you can actually bind to that schema, right? And so a better way I feel of doing that, and I'll just show in here in YAML, is rather than telling Hibernate to generate the schema, tell it to actually do a validation. So if you're running against a container image that already has a schema, let your when your tests start up or when your application starts up, validate that the annotations that you wrote on your entity class actually generate the proper DDL to match the schema you're trying to connect to. And that's what I did for all of these examples. So that's why I built a custom image just for that.
Cool. And let's see. Shane is asking, how do principles like user credentials, sessions, and other stuff differ between Quarkus and Spring? I'm interested in Quarkusizing a Spring project, but didn't know if it's a lot of work or not for this part. So what do you think?
So in sessions, are they talking about, I assume, HTTP sessions? So forgetting about the technology choice under the covers, when you start talking about distributed applications, like I'm going to deploy N or instances of the same app, the HTTP session thing where you're putting something in the session and storing it per session maybe isn't the best way of doing things in a microservices world, because in microservices you want some kind of backing service. So if I wanted to do that, why not just store it in something like Infinispan or Redis or whatever, right? So to me, that would be a better, whether you're doing Quarkus or Spring, that's probably a better approach for microservices. That being said, like I said, the underlying engine for Quarkus is the reactive netting, and Quarkus sits on top of Eclipse Vertex. So if you're familiar with Vertex, Vertex is a very slim, lightweight, and high performant reactive framework, and so Quarkus sits on top of that. And so under the covers, the reactive engine handles a lot of that stuff for you, but it's kind of abstracted away from the developer a little bit. I don't know if that
Cool.
completely answers the question, but
Mhm. Yeah, understand. And John Klinger is asking, why didn't the book cover the Quarkus Spring compatibility APIs?
I'm gonna give him hell afterwards. So so the book talks about, there are these Spring compatibility APIs where you can take a Spring application and you can, with minimal invasiveness, I don't want to say run it on Quarkus, but change it into a Quarkus application. And we have, and I can go back to the browser and show you, there's a workshop or a self-paced tutorial that'll take you about 45 minutes if you're interested in it, that kind of take Quarkus, look at this, like the Spring MVC, Spring Data JPA annotations and whatnot, and kind of put an adapter layer at build time on top of it, so that you don't necessarily have to change your code. And those are good for getting started. But I don't think and again, I'm not part of the Quarkus team, so I can't speak for them, but I don't think the intent there is to kind of start off and build fresh or new applications that way. They're meant for, hey, I want to get started with it, or I've got some applications that don't use a lot of like in-depth Spring things. So things like if I'm doing like really complicated exception mapping, or as an example, you're going to run into edge cases really fast. So it's good to kind of play around and learn about Quarkus. But if you're going to start fresh, I would start fresh. And the book has a section in chapter 2 that kind of says the same thing that I just said. But the focus of the book was looking at Spring and looking at Quarkus and kind of merging them together.
Another question here from Oro. How do you solve hypermedia? Any equivalent of HOS?
I believe Quarkus does have it. I personally haven't played with it, but I believe I can go out to. I mean, I don't know if I can take that offline and look. I believe there is an extension for something. I can't speak personally to it because I haven't done it.
Okay, cool. This is a cool one. Matthew is asking, for Spring Boot, it's possible to generate Swagger documentation for your API. Is this as easy for Quarkus?
So let's put a caveat there. The generation of the Swagger stuff isn't part of Spring Boot, right? Spring doesn't have that. You've got to use something like Spring Doc, or what's the other one? Spring Fox. There's a few open source projects out there, but it's not part of Spring. In chapter 2 or chapter 3, I actually talk about that, and I showed Quarkus does have an extension that's just built into the framework that can do that. And I could take my resource classes and annotate them or generate open API stuff, and it looks the same, but yes.
Oh yeah, if you add the Open API extension,
Yes.
generates it for you, and in Dev Mode you have the Swagger UI added for you automatically as well.
Yep.
And that's super cool. And Dominic is asking, any Spring feature you miss as you have like a Quarkus equivalent for?
Any Spring features I miss that there isn't a feature for? Is that?
Yeah.
That's a good question. I haven't come across anything yet. I mean, I know what, so when I didn't show it in the demo, but when you start getting into like reactive or event driven, Quarkus, it's just kind of built in with like the reactive stuff, the microprofile reactive extensions, and the Spring I don't want to say the Spring version of the Spring answer to that is, but the way you would do that in Spring is with Spring Cloud Stream or Spring integration and whatnot. And one thing I found that actually wasn't there in Spring, or that maybe I just didn't know how to do it. I mean, I banged my head against the desk for hours before I just wrote something myself. Is a way to think about a use case where I have an app that's listening to messages from Kafka, or some kind of message broker. It doesn't have to be Kafka, and that I want to serve those as service end events. So listening and then publishing and having to like store the stream and wait for subscribers to subscribe to the stream, because you don't want to just buffer those in memory, because you could run out of memory real fast if you get a lot of events. I could not find anything in Spring Cloud Stream or Spring integration to do that. I had to kind of drop down to Project Reactor. Has this concept of a sync that manages subscriptions and whatnot. Whereas Quarkus, it was just built into the event bus. Like it's just there. It's part of Vertex. It's part of the underlying Vertex framework.
Mhm. Yeah, the only thing that I think that Quarkus didn't have, like when I needed to talk to two separate databases, the first versions of Quarkus, you couldn't do that. But now I think it's solved. So for my project, at least, I can do everything. But one thing that I really miss in Spring when I have to touch my Spring project is the Dev Mode. So once you touch Quarkus Dev Mode, you're absolutely spoiled.
And then dev services. So like you need a database or a Kafka broker or Redis or a schema registry or HashiCorp Vault or any of these other types of services that you need to run locally. Now you don't need to set up like a Docker Compose or anything like that. Quarkus Dev Mode will just spin it up for you automatically.
Mm-hmm. Absolutely. Yeah, let me see. Let me try. Oh, lots of questions. It's even hard to read it. Alfred is asking, what is the future for native images? Are there any new features coming?
New features for native images. I know, and this isn't specific to Quarkus, but I know there's the new flight recorder, Java flight recorder for growl VM that was contributed. I don't know exactly what version, but that's kind of new, and that's just across the spectrum for anything using growl VM. I'm not in the growl VM space, so I don't really track it as much. I just know I do, Maven package -p native, it works, and then I get a native image. Or if I want to do it in a container, I can do a container build and make a native image, and it's worked for the last 2 years, right? So I don't really have anything else to add to that.
Okay. Jan Milton is asking, does unit test change when using Quarkus?
Yeah, so I think I ran out of time and I wanted to show this. I don't know if you have a second. You can go back to my screen share here, my IDE. I wanted to show kind of some of the tests. And yes, Spring has its own testing framework for testing different layers of your application, right? So testing a resource versus testing like a controller class here. It's the pattern is the same. So like in this case where I'm doing do I have the right tests? Oh no, that's the repository. Here we go. So like Spring MVC uses this mock MVC thing to do tests, or you could start it up and do like test rest template or something. So Spring Webflux now you bring if you're doing reactive. So kind of one of the cool things with Quarkus is Quarkus doesn't care if you're doing reactive or not, and you don't have to do something special to do reactive or not. Spring, you kind of need to make that decision before you've written a line of code. Am I doing reactive? Am I doing blocking? Because once you make that choice, you're kind of stuck with it unless you want to rewrite your application. And so that even falls through when you start doing testing. So like the way you write your tests for Spring MVC is different than the way you write your tests using a Webflux based controller. Whereas with Quarkus, it doesn't really matter. The test is written exactly the same, but the kind of algorithm of how you do testing is the same. You take in this case, the resource or controller layer that has a dependency on your repository layer. You stub out or mock the repository layer. That way you can test your resource layer or whatever layer you're trying to test in isolation. So, the pattern is do your mocking. And in this case, they both use Mockito. They both use JUnit 5. The mocking is almost exactly the same. Like, I think it is exactly the same. What's different is the kind of the expectations and the framework inside. So with mock MVC you do it this way. With Webflux you do it another way. But in Quarkus uses Rest Assured for its testing RESTful layers. You could use Rest Assured with Spring as well. I personally never have, but you could. But even testing like your repository layer now, like I want to do like test that operation that custom operation I wrote, so I can stub out and I can have in both cases have Spring or Quarkus, run each test in an isolated transaction so that it rolls back the database after the test is completed. But you can see, I mean, they both use assert J. I mean, if you love assert J like I do, you use it in either. So it's very, very similar.
Okay. Andres is asking, what is the growl VM role in Quarkus and how is it important?
Yeah. So so this is my personal opinion here. I think, a couple of years ago, if you were to say the word Kafka, it was kind of like this shiny ball that was traveling through space that everybody was trying to catch, to say, oh, I need to do Kafka, I need to do Kafka, even if it wasn't the right fit for their use case. I think native image and growl VM is a similar thing right now. It's like everybody's got this native image, and I'm trying to move my hand to the camera here. Native image up here on this pedestal, and everybody's like trying to change. Oh, I need to do native image. I need to do native image, without thinking about, well, what are the good things about it? What are the things that you really need to think about before you go down that path, and what use cases is it really good for? So to answer the question, growl VM is a virtual machine that's out there that can take your compiled bytecode and actually translate it into a native machine binary like Linux or Mac or Windows or whatever. But during that process, it does like a tremendous amount of aggressive dead code elimination. So not just in your application, but if you formed a dependency graph of all the dependencies your application depends on, and then you opened up all those jars and you took all those classes out and you threw them in a directory, Graal VM would go through all of that and look to see, is there a static binding at build time where path can flow from one method in one class to another method in another class, and anything that didn't have a path, it just threw away and got rid of. And once it was done, it would form this binary, and that's what makes it super small and super fast to start up, because there's not a whole lot of, in air quotes here, stuff that's in it. That being said, there are drawbacks to that. Like, think about monitoring. If you're using agent-based monitoring, like you attach an agent to your JVM, like a Dynatrace type thing, that's not going to work in native image because there's no JVM, right? It's just like running any other native binary on the machine. So you've got to figure out what your monitoring story is going to be. It's really good for short living processes. So think about serverless, like running Lambda functions or Azure functions or whatever, pick cloud provider of choice, or an OpenShift or whatever. Being able to quickly start these things up, have them do some work, live for a while, and go away. But historically, like the Java runtime, and especially the just-in-time compiler, is really, really good about watching your application over time and optimizing it based on what's going on in the JVM, and you don't get that in Graal VM. So if your process is like really memory intensive and really long running, not saying it won't work, but the JVM might over time outperform the native image.
Cool. Yeah, we're already on top of the hour. So last question. Vinicius is asking, how about the exception handling layer with Quarkus? Do we have a base class similar to the response entity exception handler in Spring to treat the runtime exceptions?
Yeah, so there's a few different ways to do it. When I've done like exception handling, you can always throw those exceptions. I actually wrote an article on DZone a while back about exception handling in general, because there's always compile time versus runtime. Checked exceptions are good, checked exceptions are bad, runtime exceptions are good, runtime exceptions are bad. But we can have that conversation another time if you want. But essentially, with Spring, you can do it a few different ways. You can do like exception handlers. You can throw, I think it's response status exception, where you can customize the point. Quarkus sitting on top of JAX-RS has all that same stuff. So if you look in the JAX-RS spec, there's like a generic, I think it's web application exception. And someone can correct me if I'm wrong. I could be the wrong names, but there's a base level exception that's like something bad happened and you can customize the thing. But there's also like smaller, I don't want to say smaller, but like sub exception types for specific use cases that you can throw. Or you can, like I did in my response class, you can return a response object that has whatever you want, which is similar to the response entity class in Spring.
Mm-hmm. Cool. Well, Eric, I'd like to thank you for this amazing talk and congratulate you for again one more time for the book because it's great content and you can tell that the audience was super interested because we had a lot of questions and comments. So thank you very much. And if you have anything else to present, please reach out to me and we can schedule something new for you.
Yeah, and if you, I don't think you have my Twitter handle. I'm not a huge tweet person, but if anybody has questions that they didn't get answered and want to reach out through Twitter or whatnot, happy to start a conversation there. I think it's just at edandrea.
Okay, cool. Yeah, well, thank you very much and hope to see you soon in our next DevNation offering. Bye.
Bye, everyone.